Hello, guys. Welcome to another episode of Cuda Education. Today, in Apple Metal, we are continuing our journey of defining some basic concepts. So, the concept for today is render pass. Okay, so what is a render pass? Let's start from scratch again. A render pass is a per frame description of which textures you are rendering into, so color depth, stencil attachment, etc. What to do with those textures at the start? Do you want to clear the textures for the frame or load new textures? What do you want to do? What's your, what's the baseline? And what to do with them at the end? Do you want to store the frame or discard the frame? The render pass does not choose shaders and it does not know how to draw. Those things are the pipeline's job, which we discussed in a previous episode. Okay, so basically, the render pass it's defining the render target. So we're rendering stuff. Where does it go? Okay, and at the start of a frame, do we clear the frame to like a background color, to like a blue color, a red color, a gray color? What do we do with the frame, right? At the start, right? And what do we do with the frame once we're done with that frame? Okay, so do we store that frame or do we discard the frame? The render pass, it's a per frame thing. So every frame has its own kind of render pass situationship, right? It's a per frame thing. You also have to take into account, the render pass has to deal with this. What happens if the size of the frame changes? Okay, so if the size of the frame changes, then everything associated with the render pass also, has to be updated. This is kind of one of the reasons why the render pass is on a per frame basis. So, for example, if I change the frame, um, you know, what happens with the triangle, right? What happens with in this case, the triangle doesn't change its shape, but you might have instructions where it does, right? So, this is render pass is a per frame thing. And again, it deals with the textures, like basically the render target. So you're rendering, you're drawing stuff, but where does those drawings land? What are the textures associated with it? And when you begin a new frame, do you clear the frame of all things and have like a background color or whatever, or do you load like a background texture or something? And then what do you do at the end? Do you when you're done with the frame, do you store the frame or do you discard the frame? Um, you know, this discard is much preferred because you want to save memory and system resources and all that good stuff. And again, the render pass does not choose shaders, it does not know how to draw. Okay, it's basically just kind of the target. It's setting up the target for it's setting up the frame to be a target, and doing a couple extra things. So anyway, inside of our Metal 4 renderer file .m file, we have render frame to view, right? And we create a render pass encoder from the command buffer with the views configuration. So we have MTL4 render pass descriptor configuration view dot current MTL4 render pass descriptor, and then we start with the render pass encoder. This configuration, one of the things that sort of we have to understand too is that in the pipeline we talked about the pixel format, right? So what kind of pixels and what's the format of the pipeline is dealing with. The render pass also, it also has a pixel format and it has to match what the pipeline is dealing with. In this case, the MTK view, the pixel format for the render pass is inherited from the default MTK view configuration. that's a little bit outside the scope of this particular episode, but the render pass does have a pixel format, and it needs to match up with whatever pixel format you have for the pipeline, and the two have to line up in order for everything to work. So the render pass description is the render pass descriptor. Sorry. Is created by MTK view every frame. Okay. Yeah. So this configuration variable now is your render pass descriptor. And what does it contain? It contains the color attachment, right? The texture. It's basically the view's drawable texture, right? So load store actions, clear color. If you're clearing a frame, what's the clear color that's left behind, and possible depth stencil attachments. In this example, it's just attachments. Okay. The descriptor changes each frame because drawable changes. Okay. So notice here we have a render pass encoder, command buffer render, command encoder with descriptor, and then configuration. So we're inheriting basically everything from the MTK view, and putting it as associating it with the render pass encoder. The render pass becomes a render encoder, right? Render pass encoder, command buffer, render command encoder with descriptor, configuration. This creates an encoder that will record commands into the frame buffer configuration. Right, so we're going to record commands into the frame buffer configuration. Render pass descriptor equals frame buffer plan. Render encoder is the record draw commands into that plan. Okay, so the descriptor is a frame buffer plan, so that's sort of like what's going on with the frame itself, what's the pixel format of the frame, things of that nature. And then the render encoder is record draw commands into that plan. And then as you can see here, this is just a debug thing. It's like a label for the debugging and stuff. So then now we associate the render pass encoder with pipeline, and then we start to put commands. Namely this one is where we're drawing the triangle, right? So, and then we end the encoding. So the render pass encode, the render encoder is record draw commands into that plan. So basically this is draw the triangle. Configure the encoder with the render pipeline state, and that's that. What a render pass does in practice. Within a frame, the render pass defines start of pass behavior, during pass, and end of pass behavior. So the start of pass behavior, do we color the drawable? Common for a simple example, right? Or do we load existing pixels? Common for multipass compositing. So, right. So do we clear the drawable, or do we load existing pixels? So you might have multiple passes, and you're loading different pixels onto the frame. So that's start of pass. So start of pass behavior. Let's repeat. Do we clear the drawable? Right. Common for simple examples. Do we clear the drawable? So we're clearing it to our default value for the frame, or do we load existing pixels? If you're doing multiple passes and maybe you're putting a GUI on there, or you're doing some other stuff, separate processes for that frame, you might have multiple passes, right? And then during the pass, so that's start of pass behavior. During the pass, draw calls write fragments into the render target. So remember, the render pass does not know how to draw. What it does is during the pass, it draw calls write fragments into the render target. So sort of, the render pass is sort of preparing the canvas for you to paint on, right? So that the draw calls can do its thing. So it writes the draw calls right onto the render target. And then end of pass behavior Do we store results so they can be presented, or discard them to save bandwidth or system resources, right? So this is where the store or discard discussion comes, right? We want to generally discard the frame after we have presented to the screen because we don't want to eat up system resources. Your app eventually presents the drawable, so the results must be stored / presentable, okay? And then some side notes. The pipeline is compiled assuming certain attachment formats. The render pass provides actual textures with formats. They must match. So this is again back to the pipeline format and the render pass format. Pixel formats have to match. And then we have, we have to make sure that those two formats agree. So just as a summary, the pipeline is what code runs and what formats it writes. Okay, so that's what the pipeline is. The render pass is which textures exist this frame and what happens to them at the start and the end. They must agree. Okay, so anyway, guys, I know this is a little bit abstract right now. I completely agree and understand. I think just what we want to know is that a render pass sort of prepares the frame, right? There's a certain level of configuration that happens with the render pass. For our simple triangle example right now, what happens is that we inherit a lot of the configuration from the MTK view, which is sort of a higher level thing that happens before we even start talking about render pass. So, and then we have the render pass encoder, which deals with, it's recording draw commands into the plan, into the frame. Okay, so we have our render pass encoder. Notice that as soon as we start talking about render pass encoder, we have a command buffer here that has stuff associated with it. Okay. And then we basically do a draw command here where we are drawing the triangle that we see, and then we end the render pass encoder, finalize the render pass encoder. This part, configure the encoder with the render pipeline state. So we're actually, we're making sure the encoder and the pipeline match up together so that everything works fine. Again, the pipeline is what code runs and what formats it writes. The render pass is which textures exist this frame and what happens to them at the start and end. They must agree. A little bit abstract, guys. I'm not gonna lie. Render pass is one of the more it's one of the more difficult things to appreciate. Just because you kind of have to get your hands dirty in code and sort of play around with it with maybe more examples before you get a full appreciation of it, right? But we do configure the render pass, and then we have the render pass encoder, which is basically tasked with putting, putting the draw calls, associating the draw calls with the particular frame. And here is where we draw the triangle as part of the render pass encoder, and then we finalize the render pass encoder. And notice that the render pass encoder and the whole render pass discussion is encapsulated within the command buffer. So the command buffer starts here, begin command buffer, end command buffer, right? And notice that the whole render pass descriptor itself and the render pass encoder is inside of that conversation, because we end the encoding here. And I guess the render pass encoder starts here. I guess we initialize it here, but then we start it here. Okay. So that's inside of the command buffer conversation. Okay. So that's that for this episode. Thank you guys for watching. Have a great day.